Hello everyone. Welcome to the Semester 5 Laboratory Practice 4 module conducted by the Department of Electrical Engineering, University of Moratuwa. This video is about the synchronous generator practical which falls under the electrical machines and drives subject area. For the theory part of the practical, we will learn the basics of synchronous generators. We will learn about what is a synchronous generator, construction, working principle, equivalent circuit, open circuit and short circuit tests, generator synchronization, and finally the applications. First of all, let's understand what is a synchronous generator. Okay, what is a synchronous generator? A generator is an electrical machine that converts the mechanical power input from the prime mover into AC electrical power at a particular voltage and frequency. A synchronous generator runs at a constant speed called synchronous speed at all times, giving it the name synchronous generator. This is a simple diagram of synchronous generator construction. Here you can see the major components of a synchronous generator such as rotor, field winding, stator and stator winding. Rotor has a DC winding called the field winding which should be energized by supplying a DC current. Then the rotor produces north and south magnetic poles. When the rotor is rotated by the prime mover at constant speed, a time-varying magnetic flux is applied to the stator. The three-phase winding on the stator then generates a balanced three-phase voltage. Frequency of this generated voltage is related to the rotor speed and the number of poles as shown in this equation. This is the per-phase equivalent circuit of a synchronous generator. In the open circuit test, generator is run at synchronous speed for different values of field current and then we measure the open circuit voltage at the output terminals. In the short circuit test, generator is run at rated speed for different values of field current and then we measure the short circuit current at the output terminals. This is the open circuit and short circuit characteristics of a synchronous generator plotted using the readings from open circuit and short circuit test. We can determine equivalent circuit parameters such as synchronous reactance using these curves. When we need to bring a generator to work in parallel with the live generator which is already connected with grid, we need to ensure that both generators have same frequency, same RMS line voltage, same phase sequence and same phase instance. This procedure is called generator synchronization. There are mainly two techniques of generator synchronization, which are dark lab method and synchroscope method. In this practical, we will focus on the dark lab method. Synchronous generators are mainly used in power generation and in any other application where a stable speed is required. Also, synchronous generators preserve the power factor of a power system.
Let's observe the circuit for the open circuit test. Here, the synchronous generator is coupled with a DC motor. Hence, the DC motor is the prime mover of synchronous generator. J3 is the field winding and the star connected windings are the stator windings of generator. Now, let's connect the circuit. Here you can see the connected circuit. The positive terminal of DC supply is connected to this voltage dividing resistor. The voltage dividing point is connected to the ammeter's plus terminal. The other terminal of ammeter is connected to point J. Between point J and K, there is the field winding. Then K is connected to the negative terminal of DC supply. This voltmeter, which measures the open circuit voltage, is connected to point U and V. U, V and W are the stator winding ends. Here you can see another resistor. This resistor is used to vary the field current of a DC motor. And finally, you can see the tachometer. Now turn on the DC supply. At the beginning, this dial should be at this position. This is the start of the DC motor. This bulb indicator shows that we have applied the DC power supply. Now let's switch on from here. This is used to increase the field current of DC motor. Now let's rotate this until the tachometer shows a near value to the synchronous speed. Here the synchronous speed is 1500 rpm. Using this fine-tuning resistor, we can tune the DC motor field current to have the generator synchronous speed. Now take the open circuit voltage reading and the field current reading. Change the resistance now so that we have an open circuit voltage of 40 volts. Take the ammeter reading as well. Then again, change the field resistance and make the open circuit voltage to 60 volts. Take the ammeter reading. Likewise, we have to increase the open circuit voltage 20 by 20 volts up to 270 by varying the field resistance, and take the ammeter reading at each step. So these are the practical values obtained in this open circuit test. Alright, now we are stepping up to short circuit test. As you can see, the field side remains same, but two stator windings have been short circuited through an ammeter. So now let's test this circuit. Now, as I said before, while keeping all other connections as they are, just the voltmeter has been replaced by an ammeter. The ammeter is connected to U and V terminals. Now power on the circuit as we did in open circuit test, and the starter should be at this position. Now rotate this dial so that the speed of DC motor comes to the generator synchronous speed. So this is the generator field current measuring ammeter. The range is 0.3 and the field current is 0. This ammeter shows the short circuit current. The range is 5 amperes. At this moment, ammeter shows the minimum short circuit current. Then change this field resistance and make the short circuit current to 1 ampere. Then take the field current reading. Likewise, by changing the resistance, increase the short circuit current 1 by 1 ampere and take the readings up to the rated current of generator. These are the observations obtained from short circuit test. Next we have the load test for an inductive load. This means that the power factor of the load is 0. Here is the circuit for this test. Observe it well. Now let's take a look on the connected circuit. The field circuit is remaining as same, but the stator side connections have been changed as you observed in the circuit diagram. First, an ammeter is connected to point U. And the other terminal of ammeter is connected to the inductive load. This voltmeter measures the voltage across U and V. U, V and W are the stator terminals. And this is the three-phase star-connected inductive load. These 2 points are the terminals of one inductor coil. These 2 and these 2 are the terminals of other 2 inductor coils. This is the common point of star connection. This black wire is connected to point U through ammeter. This blue color wire is connected to point V. This green color wire is connected to point W. So this is the connected circuit for load test, and now let's take the readings. At the beginning, the inductance should be at its maximum value. Then switch on the DC supply and turn on the motor as we did in previous 2 tests. Then increase the speed using this dial up to a value beyond synchronous speed. Now, by changing this resistance, make the line-to-line voltage to 240 volts. Now, by using this fine-tuning resistor, decrease the speed to the synchronous speed, which is 1500 rpm. Take down the armature current reading. By changing the inductance, now increase the armature current by 0.5 amperes and take the voltage reading. Likewise, increase the current value by 0.5 ampere steps by varying the inductance. and take the voltmeter readings. These are the values obtained practically for inductive load test. Next part is the load test for resistive load. This means the power factor of the load is unity. You then observe the circuit on the screen. There you can see that three-phase star-connected inductive load was replaced by a three-phase star-connected resistive load. Now let's see the actual circuit connections. As I mentioned before, the inductive load has been replaced by the resistive load. That is the only change done to the previous circuit. You can see the star connection with the common point. Now turn on the DC supply. This dial should be at this position and turn on the circuit breaker. Then increase the speed using this dial up to a value beyond synchronous speed. Then, by varying this resistance, make the line-to-line voltage to 240 volts. Now, the stator line voltage is 240 volts and the speed has come to the synchronous speed. Initially, all these knobs should be at off position. At that point, the armature current is 0. Now, rotate one knob and read the current and voltage readings. Now rotate the second knob and take the voltage and current readings. Likewise, rotate the knob by knob and take the voltage and current readings. These are the values obtained practically in this resistive load test. You must write all the observations of each test in your observations sheet. Synchronization is the second part of the practical. This is the circuit for the synchronization. Here we are using the dark lamp method. Let's observe this synchronization process practically. But before that, let's connect the circuit. These are the national grid supply terminals. Now, connect these wires to grid side terminals. These wires must be connected to the terminals of one side of bulbs which are used for dark lamp method. Same wires are connected to the stator terminals as well. Two sets of three-phase stator terminals are connected through this synchronization switch. And the other side of bulbs are connected to the other set of stator terminals U, V and W. Now switch on the DC supply and run the generator prime mover to a speed value somewhat beyond the synchronous speed. Then vary the field side resistance so that we may have the generator output line-to-line voltage of around 235 volts, which is the grid voltage. Then, by using this fine-tuning resistor, make the speed of generator to the synchronous speed. Now, switch on this switch to have the supply from national grid. Now you can observe that 3 bulbs are blinking. When all the lamps are getting dark, the synchronization switch must be closed. Now I am ready for the synchronization. Now all the bulbs are getting bright, and now all the bulbs are getting dark. So now I close the switch for the synchronization. So that is the end of the experiment. As the theory for your lab report, first derive the equation for the terminal voltage of synchronous generator for load current I. Then prove that per unit saturated synchronous reactance is equal to 1 over short circuit ratio. Then, for calculations, obtain the following. Make sure to mark axis, scale, titles, legends when you plot the graphs. For discussion, answer the following with descriptive answers. Now, we have come to the end of the video. We hope that you received a clear understanding about the synchronous generator, basic tests, and synchronization process. Thank you very much for watching.